Alright guys, so I'm going to go through and explain these pretty quickly, and if you have questions, come on into my room. Okay? Alright, so the first one tells you, and this is going to be both of the reviews that you've been given. It asks you to convert from 2.5 moles of CuO into molecules. So I start in moles, put moles on bottom, molecules up top, and I use Avogadro's number there. Okay, notice 2 sig figs is my final answer. Next one, it's asking you to go from atoms to grams. I can't go directly to grams, so I need to go first from atoms to moles and moles to grams. So I've got 1.5 times 10 to the 24th atoms. I'm going to put atoms on bottom, moles up top, moles on bottom, grams up top. So this is Avogadro's number. This is the mass of the molar mass of gold, sorry. So then I divide and then I multiply. This has 2 sig figs, so I round this to have 2 sig figs as well. The next one, guys, notice I'm giving you a name, so you're needing to write out the formula before you get started. So zinc always has a +2 charge, Cl has a -1 charge, so when I cross my charges, it becomes ZnCl2. Then I put moles on bottom, grams up top, and this is the molar mass of zinc chloride. And you need this in order to find that. Okay, you can't just do it from the name. You don't know how many zincs you need, how many chlorides you need. Okay, so when I multiply, I need 2 sig figs, so this ends up being 570 grams. Next one, how many molecules are in 0.1 grams of aluminum oxide? Again, you need to cross your charges. Al has a 3+ charge, this is a 2-. So I then start out. So I got grams here, grams on bottom, moles up top, moles on bottom, molecules up top now. Okay, because remember you can't go directly, you have to go first to the mole. So this is the molar mass of aluminum oxide, Al2O3, and then 6.02 times 10 to the 23rd molecules. 1 sig fig, so I round this so it has 1 sig fig as well. Alright, here I've got that many molecules, so I'm trying to convert it into grams again. Okay, so I put molecules on bottom, moles up top, moles on bottom, grams up top. I need to find this formula first of lead-4 nitrate. So lead has a +4 charge, which I told you. NO3 has a -1 charge, so when I cross my charges, I get PbNO3 in parentheses 4. So notice I have 1 Pb, 4 Ns, 12 Os. So my molar mass, I got 455. Okay, again, 2 sig figs, so it's going to be 420 grams. 6, how many grams is a single molecule of dinitrogen pentoxide? This is going to be N2O5. So I start with one molecule, because a single molecule, that's your given. Molecules on bottom, moles up top, moles on bottom, grams up top. This is the molar mass of N2O5. That's how many molecules, so I need to divide and then multiply. Make sure, guys, again, that this is in parentheses, or else you'll accidentally multiply the whole thing by 10 to the 23rd. So I need 1 sig fig, so 3 times 10 to the -23rd. Here, I start with 5.7 grams of a compound and of an element in a compound, X, and 6.6 grams of the other element. So to find the percent composition, I need to add these together to get the total mass of the compound, and then take each of them and divide it by the total mass. So 5.7 divided by 12.3, 6.6 divided by 12.3. And notice this is 2 sig figs, this is 2 sig figs, so I get 46 and 54. If, guys, you don't add up perfectly to 100 due to your rounding with sig figs, I'm totally fine with that. 99.5% is fine. It's just the 90% or the 105 that is wrong. All right, 8, if a 10.2 gram sample of aluminum, this of carbon, that of oxygen, we need to find the percent composition of the whole thing. So the first thing we need to do is find the total mass, and so we get 46.1. Then take the mass of each of them and divide it by the total. Make sure you keep correct with your sig figs, and so that's what I get. Okay. Next, if a 12.5 gram sample of has 2.4 grams of carbon, what's the percent of carbon and oxygen? Well, I know this is really easy. 2.4 divided by total mass is 12.5. That's going to be for carbon, so I get 19%, 2 sig figs. I don't know the mass of oxygen. The total mass of the compound is 12.5. The mass of just carbon is 2.4, so now I need to subtract. So 10.1 divided by 12.5. And notice this doesn't add up perfectly to 100%, but it's pretty dang close. For a compound whose formula is this, find the mass percent. So I need to find the total mass of this, which I get to be 247, and then take the mass of sulfur divided by the total mass, and then the mass of silver and divide it by that. Notice there are 2 silvers, guys, so you need to multiply the molar mass of Ag by 2. Okay, and notice I'm keeping true to my sig figs, even though it's not going to add up perfectly to 100. Okay. 11 can be slightly tricky. Just remember that you've got 4 S's, 6 O's. Okay, and so your total molar mass is that, and then you divide each of them, each of the molar masses of the element by the total mass. So if you notice, for example, there are 4 S's here, and so therefore the mass is 96. Or sorry, not 96, 128. Okay, divided by the total mass, and then for oxygen, 96 divided by that. All right, for empirical formula, guys, you're going to take the mass of each of them. You just assume that the percent is the mass, so 92.24% becomes just grams. You convert it to moles, and then you divide by your smallest number of moles. And so you just get CH. Okay, not too bad, I hope. Same thing here, but you start with grams, so you find the number of moles, and then divide by your smallest number of moles. And so what I got was SNO2, and then I asked you to name it. So since oxygen has a -2 charge, and this is a 2, there are 2 of them, that's -4. So tin needs a +4 charge, so it's tin 4 oxide. Here, guys, you just need to reduce. Okay, the most reduced form is your empirical formula. So this becomes CH because I divided by 6. This becomes C4H9 because I divided by 2. This is already completely reduced. This you need to divide by 2. This you need to divide by 13. Okay. Next page. Okay, so this, guys, I'm being mean, but I want you guys to feel super comfortable writing out formulas. The charge of, I need to write out the formula for this. Okay, charge of potassium is +1, Cn is -1, so I get KCN. And then for this, guys, I'm asking you to find the grams of potassium. So you need to go from grams of KCN to moles of KCN, from moles of KCN to moles of K, then to grams of K. So I'm going to put the mass of KCN on bottom. Notice in 1 KCN there is 1 K. And then I'm going to put the mass of just K up top. Okay, so if this were K2CN, there would be 2 moles of K in every 1 K2CN. Alright, and then this is my answer because there are 2 sig figs. Again, you need to write the formula. Al has a +3 charge, OH has a -1 charge, so it's AlOH3. Okay, and then I crisscross swoosh. I'm going to put moles on bottom, grams up top. This is the molar mass of AlOH3. Okay, let me know if you disagree with any of my work. CuO again, copper 2, 2+, oxygen 2-, so I get CuO. But notice here I actually didn't need the formula because I'm going just from moles to molecules. So it's always going to be 6.02 times 10 to the 23rd that's here. Next one, it's wanting you to go from 2.4 grams of sodium to grams of sodium chloride. So I'm going to put grams of sodium here, crisscross swoosh, grams, moles of sodium there, moles of sodium chloride, and then moles of sodium chloride in grams. So this is the mass of just sodium, this is the mass of sodium chloride, and then when I multiply, I end up getting just 6.1. Here, guys, it's a tiny bit tricky because I tell you the mass of strontium is 2.45 and the mass of strontium oxide is 2.89, so that's the total mass, so 2.45 divided by 2.89. But then I also need to find the mass of just oxygen. So if I were to answer that whole thing, because obviously it doesn't ask, I'm wanting to make sure you understand it. So the mass of oxygen is 0.44 divided by 2.89. Right. For here, guys, I want to find the percent composition of aluminum in aluminum sulfide. Okay, so the total mass I get is 150. So I take the mass of aluminum, 53, and then S is 96, and I divide it by the total mass. Okay, so notice you had to find the formula first. So you got Al2S3. That's not given to you in the name. This is a really pain in the butt question. I would only ask probably one step of it. So this is the typical find your number of moles, and what you end up getting when you divide by your smallest number of moles, which is 3.123, you get 1.33 and 1.17. Now, what I would probably do is cover up the O, and I would just have these two. So you just have to do one of these steps. This requires 2. If you notice with 1.33, if you multiply the entire thing by 3, because you can't keep dividing, that's the smallest number. So now I have to start multiplying. If I multiply 1.33 by, let's say, first 2, I would get 2.66, which I don't want. I need it to be as close to a whole number as possible. So if I multiply by 3, I get 3.99. Okay, so I'm going to multiply everything by 3. So I get 3, I get 4, and then this is 3.51. So what you should notice here, to make 3.51 a whole number, I can just multiply it by 2, and that gets 7. So this becomes C6H8O7. Okay, so probably on a quest just be one of these steps, not both of them, because that's mean. For your molecular formula, guys, you take your molar mass of the molecular formula, which was given to you 219.9, and you divide it by the empirical mass. Now, the empirical formula is P2O3. Okay, and so the mass of this, your empirical mass, is 109. So when you divide these two guys, you're always going to get a whole number. And so here you got 2, so now you're just going to multiply this by 2. So it becomes P4O6. And that's it, guys.